Good morning, students. Welcome again to this online lecture series on fundamentals of computers and programming for problem solving. In the previous sessions, we completed what is number system, what kinds of number system we have, what are the uses of number system, and how various number systems are represented and how they are converted from one to another. Topic that we are going to cover is number system arithmetic, which is the science of arithmetics, which is the science of arithmetics of number system. So, how the number system, how the various numbers of the different number systems are added, subtracted, multiplied, and divided from each other. This we are going to cover in this lecture. So, the learning outcomes of this particular lecture will be we will be able to understand the various number system arithmetics, that is addition, subtraction. Also, we will be able to complete the multiplication and division, because multiplication and divisions are to be considered as repetitive additions and repetitive subtractions. Okay, and after that we will do the subtraction in with another method. We will do individual addition and subtraction first for all the number systems, and then we will do subtraction as an addition to a negative number. In addition to a negative number, we will see the concept of negative number. This is the important concept. So for the representation of a number as a negative, we have two methods. They are called complement representation. First method is r's complement and another method is r minus 1's complement. Okay, and subtraction using, then we will do subtraction using r's complement, then we will do r minus 1's complement. Okay, so this is how this lecture will go, and after that you will be able to do various arithmetics on the arithmetics of the number system. Okay, so let us start from addition of binary numbers. Okay, binary numbers, they have two symbols, 0 and 1. Okay, so there can be various additions of these two symbols only. Okay, these two symbols can be added in following combination: 0 may be added to 0, 0 may be added to 1, or 1 may be added to 0, or 1 may be added to 1. Okay, these four can be the four addition combinations of binary digits. Okay, when 0 is added with 0, the result is 0. When 0 is added with 1, the result is 1. When 1 is added to 0, is all the same thing, and the result is 1. This is an important concept to note. 1 plus 1, 1 is added to 1 is what we will get. Okay, now 1 in binary is 1 in decimal, right? 1 in binary is 1 in decimal, and next one is binary is 1 in decimal also. So if I add it in decimal, it gives me 2, right? And if I convert this 2 into binary, we get 1 0, not 10. It is not 10, it is 1 0. Okay, so this 1 0 will be used here. So 1 plus 1 will be 0 as a result, and 1 will be the carry to the next bit. Okay, so let us understand this with the help of one example. Suppose I want to add this. Okay. So I want to add these two binary numbers. Fine. One is added to. Okay. We will start from here. Always start from LSB. Right. Okay. One is added to one. The rule is will be used is this, or I will say the rule used will be this. Okay. So 1 plus 1 will give 0 as a result and 1 as a carry. Okay. Now 0 plus 1 is 1, but this 1 plus 1, okay, this 1 plus 1 is 0, fine, and carry is again 1. 1, 0 plus 1 is 1, and 1 plus 1 is again 0, and 1 goes to the carry. Okay, now see this 1, 1 is again 0 and 1 to the carry. Here 0 0 is 0 and remaining is 1. 1 plus 0 is 1. 1 plus 0 is 1 and 1 plus 0 is 1. So this is the result of addition. Okay. Now how you are going to verify this? Can we verify this? Yes. First you convert this into decimal. Okay, this is 2 raised to power 1, 2, 3, 4, 5, 6, 7. So 2 raised to power 7 plus 2 raised to power 5 plus 2 raised to power 3 plus 2 raised to power 2, 1, 0, 1. Okay, and the next number is 2 raised to power 6 plus 2 raised to power 2 plus 2 plus 1. Okay, so this number goes as 128 plus 32, that is 128 plus 32 plus 8 plus 1, and this is 64 plus 4 plus 2 plus 1. Okay, so this will be 169. Okay, plus you have 71. This will give you 9 and 1 0, 7 6 13 1 14 and 240. Okay, now if I convert 240 into binary, okay, I can take directly 2 raised to power 7, that will be giving 28 128 plus 2 raised to power 6, that is 64. The total becomes 192. Then I will take 32, 94 and 1 192, 194 and 224, and 2 raised to power 4 is 16, right? Okay, that gives you 240. That is, you place 7 at the 7th bit, you place 1, 6th bit you place 1, 5th bit you place 1, and 4th bit you place 1, and remaining 4, 3, 2, 1 and 0. Can you match this? Yes. So this is adding 169 plus 71 is 240. This is how you can verify also the addition, right? Okay, let us perform one more example. Let us do one more example. Okay, 1 1 1 0 1 1 0. Okay, and we will add 1 1 0 1 1 0 1 1. Okay, now we will add these two binary numbers. Remember the rule, we will start from LSB. Okay, we will start from LSB. 0 plus 1 is 1, right? 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0 and carry 1. Okay, this is an important. 1 plus 1 is 0 and carry goes 1. Okay, 0 plus 1 is 0. 0 plus 1 is 0. Sorry, 0 plus 1 is 1 and 1 plus 1 is 0 and carry 1. Okay, 1 plus 0 is 0, 1 and 1 plus 1 is 0 and carry goes 1. Now see this carefully. This is another example of having three ones. Okay, so three ones means 1 plus 1 is 0 and 1. Okay, so what we will do, we will solve this separately. I will tell you how to solve this. This 1 1 and 1. Now we need to add all of them. Okay, if we take them, they becomes 3. Okay, these are binary digits, right? And if I write their decimal digits, they are also 1. Okay, they are also 1. And if I add them, this becomes 3 in the decimal. And if I write it in binary, it will be double 1, right? So what will be the result? This double 1 will come here, and since there is a place of only one digit, so unit digit we will place here, and unit digit we will place here, and we will shift the remaining one. This is the unit digit and this is the tens digit. Okay, so 2 raised to power 0 digit we will place here, and 2 raised to power 1 digit we will place in carry. So again triple one are there, so the result will be again 1, and 1 will lead to the carry, and this one, since there are no other digits, this will be a carry which will be directly taken in the answer. So there one more important thing we need to note, that the addendums addendum. Okay, what is addendum? The number which adds. Okay, the number which adds. Okay, so addendums were of 7 bits, right? 3, 3, 6, or 2, 8 bits. Addendums were of 8 bits. But you can see the result had one 8 bits. The result had 8 bits plus 1 bit carry. Okay, 1 bit carry. Okay, so this is called an overflow situation. Overflow situation. What we call this situation? Overflow situation. The place was to store only 8 bits, and the result became 9 bits. Okay, so suppose this was the value of an integer, and this was also value of an integer. Okay, so what will happen if you add one integer into integer? You get only the result for, and the result is also stored in a integer kind of variable. So integer variable, suppose it takes 8 bits. Okay, although it takes 16 bits in C programming, but let us suppose this is one of the integer for 8 bits, and this is another integer for another 8 bits. Okay, and the result is also is an integer, because it will be added as the integers will be added, so result will be in integer only. Okay, so integers, and so result will have only 8 bits available for the storage. So this extra bit, which is which is over the 8 bits of the normal integer, this is called the overflow bit. This is called the overflow bit. Okay, this is overflow bit. Okay, and this is an important reason why you when you add for integer variable, you remember this example we did. If the value of integer a is 65535, okay, and you do a plus plus, fine. So, and when you print a, the result is 0 gets printed. Do you remember this thing? Why? Because A has the maximum capacity of 65535. For 16-bit number, 6553 means 16 bits of 1, right? And if you add 1 to it, okay, so 1 plus 1 becomes 0, carry is 1. 1 plus 1 becomes 0, carry is 1. 1 plus 1 becomes 0, carry is 1. 1 plus 1 becomes 0. So this whole becomes 0, 0, 0. And in the last, when 1 plus 1 becomes 0, a carry is an extra carry, and which is added in the last part, and this is actually overflow bit. Okay, and if you see the 16 bits which goes from here to here, this returns you 0 decimal value. So this is why adding 1 to the last value, adding 1 to the last value of integer gives you result as 0, because when this 1 is added into this number, the the actual space, which is of 16 bits, all the bits become 0. Okay, and the one that was extra is an overflow bit. Okay, and since integer does not has space to store this extra bit, this extra overflow bit, it discards it. Okay, it discards it, right? And since it discards it, so the result appears to be 0. Okay, and this is why it gets, and when you add one more to this 0, it becomes again 1. Okay, 1 2 3 4 and so on, and again it goes to 65535, and when again 1 is added, it again shifts to 0. This is why we saw that result, that when you add, keep on adding, after the range is finished, the number shift to their initial ranges because of this overflow situation. Okay, so the two things that we can take from here is, first thing is this, that what are the rules, what are the rules for what are the rules for performing addition. This is the first thing that you need to take. Second thing, when you have triple one as a situation, okay, triple one as a situation, it gives you 3 as a decimal, and which is 1 as binary. Okay, so here 1 is used as 1 is used as value, and 1 is placed as carry. Okay, so I will add this also as a result, 1 1 and 1. So all of them together give one as a result and one as a carry. Okay, so these results you need to remember for the addition of binary numbers. Let us perform some examples for the addition of binary numbers. Okay, now see this. Okay, now see this. These are binary numbers. Okay, don't get confused. 1 plus 1 is 0 and 1 goes to the carry. Okay, now this one and this one, you have triple one, right? So from the rule you can see that triple one goes as triple one goes as 1 1. Okay, so the LSB one goes here and MSB goes in the carry. 0 plus 0 is 0 and 1 is alone, so 1. 1 plus 1 is 0 and 1 to the carry. Now 1 plus 0 is 1 and 1 plus 1 is 0 and 1 to the carry. Okay, so this is an extra carry and this is the result. Okay, you can also verify this. Hmm. So you can also verify this by simply converting first this number to decimal, then converting this number to decimal, and when you add this there will be a result in decimal, and if you binary convert it into convert it into binary. Okay, so this should match with this number. If this matches, so your result is okay, otherwise it is not okay. Okay, so your practice set is, I will write this as practice A and question as question 1. Okay, so the question becomes A1. Now uh, you can perform this. Okay, these practice questions you can perform. So what are the things to remember? First thing that needs to be remember is uh, 1 plus 1 is 1 0, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 plus 1 is double 1, right? Okay, for adding any two binary number you will get maximum of this condition. And also remember the concept of overflow bit. Okay, so overflow is a situation when the result of the addition goes gets one extra bit than the addendums. Okay, and what are addendums? The numbers which are getting added are addendums. Okay, so this was addition of binary numbers. We will continue with the addition of octal and hexadecimal numbers in the next video.